Welcome back to the channel. In this video we are going to learn how to graph a quadratic function. If you are not familiar with quadratic functions, make sure to see the videos that we have already done about them, and if you are familiar, then let's learn how to graph them. Now, all the quadratic functions that we are going to see in this video will be in the form of ax squared plus bx plus c. And yeah, so first, all the quadratic functions that we are going to see are going to take the form of a parabola. How does a parabola look? They are going to look like this, facing upwards, or like this, facing downwards. And this all depends on the leading coefficient of your quadratic function. If the leading coefficient, a, is greater than 0, then your parabola is going to face upwards. If your leading coefficient is less than 0, then your parabola is going to face downwards, just like this one. So let's take a look at a quick example. If we have this function, 2x squared plus 2x plus 4, we already know that this function is going to take this shape, a parabola facing upwards. However, if we were to change this sign right here, this will make this function have this shape, a parabola facing downwards, because now the leading coefficient of this function is less than 0. So that's a very important thing when you graph a quadratic. Always take a look at the leading coefficient, see if it's greater or less than 0, and you will already know the shape of your parabola, if it faces downwards or if it faces upwards. This is also very important because if it faces upwards, you will have a minimum point in your graph, which is also the vertex of the graph and the lowest y value, vertical value, that your function takes. And if it faces downwards, then you will have a maximum point, which is also the vertex of the graph and is the highest y value, vertical value, that your function takes. An important characteristic of parabolas is that they are always symmetrical over a specific line. In this case, this line is known as the axis of symmetry, and this is a vertical line that splits our parabola into two symmetrical sides. Now, the axis of symmetry will always go through the vertex of your graph, in this case through our minimum point, since our function has a leading coefficient greater than 0, and so the shape of the parabola is upward facing. Therefore, we have a minimum point at the vertex. Now, the formula for the axis of symmetry is negative b divided by 2 times a. And if we look at our function, we have 2x squared plus 8x plus 1. Now, what is b and what is a? If we look at the standard form for a quadratic equation, ax squared plus bx plus c, a is the leading coefficient of the whole equation. So we know that a is 2, and b is the coefficient of the x term in the function. So we know that b is 8. So if we plug that in the formula, we would have negative 8 over 2 times a, so 2 times 2, so negative 8 over 4, which is going to give us negative 2, so x equals negative 2. Now, it is very important to understand that the axis of symmetry is a line, not just a value. And since it is a line, we have to express it as a function itself. So x equals some value. In this case, x equals negative 2. And since the axis of symmetry is a vertical line, it is always going to be expressed as x equals some value. Now, the axis of symmetry and the vertex have the same x coordinate. Now, this makes sense because, as we said, the axis of symmetry goes through the vertex of the function. And since this happens, we know that the x value, or the horizontal value of the x-coordinate and the axis of symmetry has to match up. And this is very important because now we know the x-coordinate of our vertex, and we will later need to find the y value of this vertex later on. So it is very important to understand that the axis of symmetry is a vertical line that splits a parabola into two symmetrical sides, and the formula for it is negative b divided by 2 times a, and the axis of symmetry has to be expressed as a function itself as x equals some value, since it is a vertical line. Now, the last step to graph a quadratic function is to find the x and the y intercepts of the graph. Now, what do x-intercepts and y-intercepts mean? The x-intercepts are the points in the function where the graph is going to cross the x-axis, the horizontal line. And the y-intercepts are the points where the graph is going to cross the vertical line, the y-axis. So in this graph, these 2 points here are going to be the x-intercept of the graph as they cross the x-axis, and this point right here is going to be the y-intercept. At this point is going to cross the y-axis. Now, how do we find these? Based on a quadratic equation. To find the x-intercepts, we're actually going to have to solve this quadratic equation and solve for x. Now, if you're not familiar with solving quadratic equations, you should go and watch our videos that explain how to do so. And in order to find the y-intercept, we are simply going to replace x for 0 and solve for y. Now, why does this work? The y-intercept is the place where the function, the line, is going to cross the y-axis. And since we know that in the y-axis, the value of x is 0, we can simply replace x with 0 and evaluate or solve for y. So in this case, if we replace 0 for x, we have 0 squared, 0, minus 0, minus 2. So 0 minus 0 is 0, 0 minus 2 is negative 2. So we just found our y-intercept, 0, negative 2. This is the point where this function is going to cross the y-axis, the vertical axis of the graph. Now we are going to find the x-intercepts of this function, and we are going to have to solve the quadratic equation and find the values of x, and those will be the x-intercepts of our graph. So we can solve this by factorization, and we are going to split this system in the middle into x squared plus x minus 2x minus 2. We are going to group this term and this term together, and this term and this term together. x plus 1, negative 2x plus 1. And so our solutions are x minus 2 and x plus 1, which finally means that x equals 2 and x equals negative 1. Now we have solved the equation, and we have now found the values of the x-intercepts of this function. So let's graph them. X equals 2, 1, 2, and x equals negative 1, negative 1. Always label the coordinates of your intercepts. And we have now learned how to find the y-intercept and the x-intercept of a quadratic function. Now, as an example, we are going to graph this quadratic function, and we are going to need to find the x-intercept, the y-intercept, the axis of symmetry, the vertex, and we're going to have to think about the shape of this function. So first, if we think about the shape of this function, we see that the leading coefficient 1 is greater than 0, and so the shape of the parabola of our function is going to face upwards, which means that we're going to have a minimum point at the vertex of our function. Now, if we think about the y of the y-intercept, we are simply going to replace 0 for x in this function, which is going to give us 0 squared minus 0 minus 2, which is going to give us negative 2. So the y-intercept of this graph is going to be at 0, negative 2. Now let's solve for the x-intercept of this function, and if you solve this, you're going to end up with x plus 1 times x minus 2, which means that x equals negative 1 and x equals 2. Those are our x-intercepts, and here they are, graphed, negative 1, 0, and 2, 0. Now let's take a look at the axis of symmetry, which is given by the formula negative b over 2 times a, which is b is negative 1, so negative 1 times 2 times a is 2, so 2, which means that the axis of symmetry is going to be at x equals 1/2. Here it is. And finally, all we have to find now is the vertex. Now, since we know that the axis of symmetry is going to go through the vertex, and we already know that the x value of the axis of symmetry 1/2 has the same x value of our vertex, we can simply place this value of x into the function and solve for y, which is going to give us the y value of the vertex, which we don't know. So if we place 1/2 into this function, 1/2 squared minus 1/2 minus 2, we're going to get negative 2.25, which is the y value of our vertex. And here it is graphed. So now we have graphed all the components of the quadratic equation. I hope this helps. If you have any questions, ask in the comments or ask the board of MAT. And thanks for watching.